1,200 million kilometres from here, a machine is lying in the dark where it fell. It sent pictures back for 72 minutes, and then the only thing listening to it dropped below the horizon. Nothing has landed that far from Earth since. This is Cosmian. Join us as we follow the one machine that reached the ground on Titan, and the machine now being built to go back. If you were handed a map of Titan's surface without being told where it came from, you would almost certainly guess at somewhere on Earth. There are rivers on it, running down out of high ground, braiding and joining the way rivers do here. And they empty into lakes and seas with coastlines, bays, islands and shallows. There is weather above all of it, because clouds form and drift and gather and break. And when they break, it rains onto ground that the rain has visibly been carving for a very long time. Titan is the only place in the solar system besides Earth where any of that is true. And then you find out what the liquid is. Almost nothing on Titan is made of the thing it appears to be made of. The rain is methane, the rivers carry methane, and the seas are full of it. And NASA's own description of those seas is that they are great lakes of liquid natural gas. The ground those rivers cut down through is not rock at all. At minus 179 degrees Celsius, water is not a liquid. And it is not soft either. It is a hard, brittle mineral. And on Titan, water ice does the job that granite does here. Even the sand is a lie, because the dunes that stretch across Titan's equator are built from dark grains of hydrocarbon settling out of the sky, and the nearest thing to them in your kitchen is coffee grounds. So Titan is a working landscape, weathering and eroding and draining exactly like ours, and it is assembled entirely out of the wrong materials. It is also considerably bigger than most people assume. Titan is the second largest moon in the solar system, beaten only by Jupiter's Ganymede and only by 2%, and it is comfortably larger than the planet Mercury. It goes around Saturn once every 15 days and 22 hours, keeping the same face turned towards the planet the whole way round, exactly as our own moon does to us. Saturn takes 29 years to get round the sun, and its axis is tilted much as Earth's is. So Titan has genuine seasons in the way Earth has genuine seasons, and each one lasts more than 7 years. What makes any of this possible is the sky. Titan is the only moon in the solar system with a substantial atmosphere, and that atmosphere is mostly nitrogen, just like the air you are breathing now, with a few % of methane mixed through it. It is dense enough to hold clouds and carry weather systems, and dense enough that a liquid can sit out in the open without instantly boiling away, which is the one condition the rest of the solar system cannot meet. That same atmosphere is also, unfortunately, completely opaque. High up, sunlight and charged particles from Saturn's magnetic field break the methane and the nitrogen apart, and the fragments recombine into heavier organic compounds that hang in the air as a thick orange smog. That smog is the reason every photograph of Titan taken from a distance shows the same featureless amber ball. It is also the reason that for 3 centuries after we first noticed the moon was there, nobody on Earth had the faintest idea what lay underneath it. The haze does not lift, and there is no gap in it, no clear season, and no window. There is a much stranger problem buried in that haze, and nobody has solved it. Sunlight destroys methane continuously, and it does so fast enough that Titan's entire supply should have been stripped out of the atmosphere within about 10 million years, which by planetary standards is barely more than an afternoon. Titan is 4.5 billion years old, and the methane is still there. Something is putting it back, and the leading suspicion is volcanoes that erupt chilled water instead of molten rock. But nobody has ever caught one doing it. The honest position is that we do not know where Titan's weather comes from. There is a clue in the air about where Titan itself came from, and it points somewhere unexpected. Instruments on the mission measured the balance of two different kinds of nitrogen in the atmosphere, and the ratio between them turned out to match the comets of the Oort cloud, rather than anything belonging to Saturn. The reading of that is fairly stark. The material Titan was built from came together in the cold outer disk that formed the Sun itself, not in the warmer disk that later condensed into Saturn. Titan may well be older than the planet it orbits, and underneath all of it, there appears to be an ocean. As Huygens fell, it transmitted radio signals that behaved as though something conductive lay far below. The best reading of them puts a body of liquid water between 55 and 80 kilometers beneath the ice, which leaves a moon with two entirely separate places worth searching. There is liquid water in the dark underneath, of the kind every living thing on Earth depends on, and there is liquid methane in the open on top, of a kind nothing on Earth has ever had to survive in. Neither one can be investigated from orbit because the haze is in the way. So at some point somebody was going to have to go down there and stand in it. The machine that did it left Earth on the 15th of October 1997, and it did not arrive for 7 years. It travelled as a passenger. Huygens was a European Space Agency probe, 2.7 meters across and weighing 318 kilograms, and it crossed the solar system bolted to the side of NASA's Cassini orbiter. For almost the whole of that journey, it was switched off to protect the batteries it would need at the far end. It was built, in close to the official description, like a shellfish. The hard outer shell existed only to take the heat of entry. Inside it sat a soft interior of instruments that could not have survived being touched by any of that heat. At Christmas 2004, the two spacecraft separated, and Huygens spent the following 21 days coasting alone towards Titan, with everything shut down and no way of correcting its course. There was no contingency in that plan, because there could not be one. If the aim was wrong, or the timers failed, or the shell had been damaged in 7 years of flight, nobody on Earth would find out. Not until the probe was already inside the atmosphere and burning. On the 14th of January 2005, it reached the top of that atmosphere and began to fall. The descent took 2 hours and 27 minutes, which is an extraordinarily long time to be falling, and it is a direct consequence of how thick Titan's air is and how weak its gravity is. 3 parachutes opened in sequence to control the drop. Somewhere in the middle of it, the probe started photographing the ground below. Because it was turning slowly under the canopy, its 2 cameras could stitch what they saw into a single mosaic, one that grew wider and sharper as the surface came up to meet it. What came out of that mosaic was the thing nobody had been able to predict. Titan had drainage. Narrow channels ran down out of brighter, higher terrain, exactly the way water cuts down a hillside on Earth, and those channels merged into larger river systems as they went. The rivers ran out onto dark, flat lowland with the unmistakable shape of a drained lakebed, and standing in that lowland were features that look for all the world like offshore islands and shoals. The scientist in charge of the camera, Martin Tomasco, put it plainly at the time. The geology showed precipitation, erosion, mechanical abrasion, and other fluvial activity, and the processes shaping Titan were much the same as those shaping Earth. Not everything worked. One of the experiments was supposed to measure Titan's winds by listening to how the probe's radio signal shifted as it was blown sideways. That measurement could not be made from space at all because of a configuration problem with one of the receivers on Cassini. It was saved from the ground. A network of radio telescopes scattered across Earth picked the probe's carrier signal out of the noise from 1,200 million kilometers away and measured the wind on another world by ear. Then, in the last few minutes of the fall, Huygens did something that is easy to overlook and quite hard to forget. It switched on a lamp. Sunlight at Titan is roughly 100 times weaker than it is here, and underneath that haze it is weaker still. so the designers had built a light into the camera and set it to come on shortly before touchdown, purely so that the last few frames would show what color the ground actually was. Huygens landed at about 11:30 in the morning, Greenwich time. It did not crash, and it did not bounce. An accelerometer recorded the impact in enough detail to describe what the probe had come down on. The crust gave way under it, and the material underneath had the consistency of loose, wet sand. Then, the heat leaking out of the machine's own body began to warm the ground beneath it. Both of the chemistry instruments watched methane gas boil up out of the soil around them. It is the most direct evidence anybody has collected that Titan's weather is real, and that the ground down there is damp with it. And in front of the camera, lying in the lamplight, were pebbles. They were small and they were rounded, sitting in what appears to be a dry riverbed. And rounded is the word that matters, because pebbles are only that shape when something has spent a long time rolling them along. Their color is wrong for rock. It is consistent instead with dirty water ice, which at that temperature is hard enough to behave in every practical sense like stone. Huygens kept transmitting from the surface for another 72 minutes. It did not fail, and nothing on Titan destroyed it. What ended the transmission was geometry, because everything the probe said had to be relayed up through Cassini, and Cassini was moving. And eventually, it dipped below Titan's horizon and could no longer hear. The probe was still talking. There was simply nobody above it left to listen. It was the first landing ever made in the outer solar system, and more than 21 years later, it is still the most distant landing from Earth that anybody has ever achieved. For a while, it did not feel like abandonment, because Cassini was still up there. The orbiter stayed at Saturn for 13 years, and it dealt with the haze problem by refusing to play the game on the haze's terms. Rather than trying to photograph Titan, it fired radar at it, and radar does not care about smog. Flyby after flyby across more than a decade, the northern half of the moon resolved into something genuinely shocking. Not lakes, but seas. The largest of them is called Kraken Mare, and it holds around 80% of all the liquid sitting on Titan's surface, which makes it close to the size of all 5 of Earth's Great Lakes put together. In 2014, Cassini flew across it, firing its radar altimeter straight down through the liquid, and at an inlet near the northern end, the seafloor came back at about 85 meters. Towards the center, no floor came back at all. The sea is at least 300 meters deep there, and that figure is not a measurement of the bottom. It is a limit, the depth beyond which the instrument could no longer hear one. In the neighboring sea, Cassini caught something that has never been properly explained. A bright feature appeared in the radar data, then vanished, then came back, and it was nicknamed the Magic Island. Waves, rising bubbles, and floating solids have all been put forward, and nobody has ruled any of them out. And then, deliberately, we destroyed the only spacecraft in the system. On the 15th of September 2017, running low on propellant and unwilling to leave an uncontrolled machine drifting around a system containing 2 possibly habitable worlds, NASA flew Cassini into Saturn on purpose. It transmitted for as long as its thrusters could hold the antenna pointed at Earth, and then it burned up in the atmosphere like a meteor. The reasoning was sound and the decision was the right one. It also meant that from that afternoon onwards, there was nothing at Saturn at all. No orbiter, no lander, no camera, nothing anywhere in the system that could look at Titan closely. Everything we have learned about that moon since has come from telescopes here at home, more than 1 billion kilometers away, squinting at the top of the haze. The gap is easy to say and much harder to feel, so here it is plainly. A child born on the day Huygens touched down is now old enough to vote. And in all of that time, nothing has landed on Titan, and nothing has flown close past it. For the last 9 years, nothing has even been in the neighborhood. There is no scandal in that, and there is no villain. It is only distance. Saturn is 1 billion kilometers away, and a spacecraft takes the better part of a decade just to reach it. Sunlight out there is 100 times too weak to run anything on solar panels, and every mission that goes has to work for years on end, without help and without a single spare part. That is not a thing anybody does twice by accident. The thing that finally changed the argument was the air. Titan's atmosphere is thick and its gravity is weak, and that combination produces somewhere that flying is not merely possible, but genuinely easy, far easier than driving. A rover on Titan would face dunes of hydrocarbon sand and fields of broken ice, and it would spend its entire working life crawling around a single landing site. Something with rotors would not. So NASA is building one. Dragonfly was chosen in 2019 as the 4th mission of the New Frontiers program. It is a rotorcraft, an 8-rotor flying machine, roughly the size of a small car, designed to land on Titan and then keep taking off again. Solar power is useless at that distance, so it carries a nuclear source instead. It is a radioisotope generator from the same family that has been running Curiosity and Perseverance on Mars for years, turning the heat of decaying fuel into steady electricity that does not care whether the sun is up. The flight plan is unlike anything ever attempted. Dragonfly will not stay where it lands. It is designed to fly roughly once every 16 Earth days, hopping tens of kilometers at a time. Over a primary mission of more than 3 years, it will work its way across the moon to somewhere between 20 and 30 separate sites, covering about 115 kilometers in total. Among its targets are the equatorial dunes and a crater called Selk. The crater was chosen for a specific reason. An impact there would have melted water ice into liquid and mixed it directly with the organic material lying on the surface. That is about as close to a laboratory for the origin of life as anyone is likely to find anywhere outside Earth, which is the actual purpose of the mission. Dragonfly is not being sent to photograph a landscape. It is being sent to find out how far the chemistry on Titan has already traveled towards biology. It will look for the specific compounds that matter to life. Then it will search for signs of 2 completely different possibilities. Life something like ours in the water underneath, and life nothing like ours at all in the methane on top. This is not a proposal or a concept study. The hardware exists. NASA published a build update in July describing the rotorcraft coming together and clearing its test program. The structural panels, the antenna, and the flight system are being assembled now, across a team running from Maryland and Colorado to France, Germany, and Japan. It launches no earlier than July 2028, and then, because this is Saturn, it has to make the crossing, which takes the rest of this decade and most of the one after it. Dragonfly reaches Titan in late 2034. Huygens is still down there. It is lying in the same dry riverbed it landed in, among the same rounded pebbles, in the dark, and nothing has been anywhere near it since the morning it arrived. In 2034, for the first time, something will fly over that ground. There is one more world in that system worth going to, and it is far smaller than Titan. It has an ocean under its ice, and it is spraying that ocean out into space, where anything passing close enough can fly straight through it and taste it. Next time on Cosmian, we go to Enceladus. Subscribe, and we will take you there.